Shall we just start with exploring some of the ideas behind good data visualization, because there are some good examples, but there might be also some bad examples of data visualization if you look at student but also published work. So how to avoid the bad ones and how to implement the good ones, I think, is the sort of million-dollar question. So I call it beautiful evidence in corpus linguistics, and I'll explain the title in a moment. This refers directly to the book that Edward Tufte wrote, an American professor who specializes in data visualization, not in language visualization, but scientific visualization in general. And this book is an inspiration for me in this particular lecture, because I'm sort of looking at those general principles and trying to apply them in corpus linguistics and corpus linguistic analysis. Right? So the direct reference in the title of the lecture goes back to this book, and I heartily recommend it to anyone. Okay. When we think about beautiful, we usually think about sort of pleasing to the senses, this sort of aesthetically beautiful. But when we think about beautiful in the context of science, and we talked a lot about science yesterday, we are thinking more about things like rich, efficient, informative, useful, and clear. Right? There's something beautiful about clarity, both in writing but also data presentation. Right? So we'll be trying to explore that type of meaning aspect of beautiful in this particular context. So what I'll be doing here is also, apart from drawing on these more general principles, I will be also talking about my own experience and the experience of the Lancaster team when developing some of the tools that present data visualization, such as the Langsbox tool and the graph call and words tool inside Langsbox, and you have an opportunity to explore those tools in your practical sessions. But for us, this has been a long journey and very interesting journey indeed, and we've learned a lot of things on the way. We've made so many mistakes, but we've sort of tried to learn from them, and sort of based on our users' feedback and experience, we sort of try to and strive to improve what we are doing. So any thoughts and suggestions in this area are always welcome. So it will be also a sort of a diary of a sort of personal journey as well, if you like. So, well, where to start? I think we have to start with our sort of basic conundrum in data visualization, and this is this, right? We have to look at different levels when we analyze corpora and corpus data, and this is just as a reminder about the sort of different levels we talked about yesterday in the intro lecture. We start with corpus sampling. We have descriptive statistics. We have inferential statistics, and now you know all about inferential statistics. And obviously then we have the linguistic interpretation. My argument today would be that good principles of visualization underline the whole process. From data sampling, when we are sort of drawing our sampling frame, so doodling our corpora that we want to sample, to the final stages of analysis, where we look at the data and try to see patterns and try to relate them to linguistic and social theory. Right? So good visualization can be crucial throughout this process, can help us throughout this process. Okay, where do we start? Well, first point to realize is that our data, linguistic data, is multidimensional. Right? There are so many different aspects about our data when you think about it. Well, just a few examples. We can look at speech versus writing, formal versus informal. We can look at a range of genres or registers, from newspaper, fiction, academic writing, Twitter language, and all sorts of uses of language in different contexts. We can look at different speakers, young and old, male and female, speakers from different social classes, if you like, especially in the British context. Speakers from different historical periods and texts produced in different historical periods, and also speakers who use who use English or any other language as their first language, or speakers who use that language as their second or additional language. So again, there will be sort of different scopes of variation there. So we have many dimensions in our language data, and the major challenge here is that we have a two-dimensional space, right? That Edward Tufte, that's a beautiful word that Edward Tufte invented, flatland, right? This is the A4 sheet or the screen that you have in front of you, right? And the challenge is to project the multidimensional data onto this two-dimensional screen. So how to approach that, right? So isn't it impossible to do that? And obviously, thinking about all the sort of different dimensions of the data, we need to choose carefully what we display and at what stage. And usually, in my experience, this is a sort of a zooming in and zooming out exercise. We focus on one aspect and then move on to another aspect, right? Because we can't usually present too many dimensions at the same time, because we wouldn't be able to cope with that cognitively, and the paper wouldn't be able to cope with that. Right? So what I would like to do as our sort of kick-off exercise today will be to give you, again, sort of a minute or two to think about these two questions. We talk about corpora, and corpora are the basis of our analysis. So how would you visualize a corpus? How would you draw a corpus? If you feel especially inspired, you can sort of doodle a corpus on a sort of a handout and discuss this with a partner, with a sort of persons or people sitting around you. So take a minute or two and talk to people around you about this. Okay, so let me just share some of my ideas and some of the ideas that we were exploring while implementing the data visualization in Langsbox and other tools. So, well, you know, take a 1 million word corpus like BO6 and a 1 million word corpus of current British English. Well, these are texts in a way, so you can sort of picture that as a sort of series of texts. I'm not sure whether you would sort of draw it as a single A4 sheet or a book, or I don't know what you would do. There are samples of books or samples of newspaper and other types of genre, and 500 of them. So you would have to sort of draw quite a few of them, and they wouldn't fit the screen here. So I just visualize that like that. When you think about a corpus, and this is again the BO6 and some of the early words there, it is a line of words for the computer, right? The computer parses the corpus as a single token after a single token, right? It processes that one by one, so a line of words, if you like, right? This is how conceptually a corpus exists for a computer. Obviously, physically, it exists as a magnetic field on the hard drive, right? But you know, conceptually, it exists as a line of words, all 1 million of them, right? Again, a very long line, if you like. Well, we can have a container metaphor, right? Something inside the corpus, and again, the question is, you know, what sort of container would we use? Would that be a box? Would that be a sphere, right? And what the implications would be. You can fit more boxes in a smaller space, right? Well, you know that if you are sort of moving house, it's very easy to have that in boxes than sort of spherical containers, right? But spheres are somehow visually more pleasing, and I think that's one of the reasons why we've chosen a sphere as a corpus that you can explore and expand to see the inside the corpus in our Langsbox tool. Right? So again, there are different metaphors, and these are all metaphorical representations, visual metaphorical representations of a corpus, and there are different implications of what we can do with them. right, for different purposes. Yeah, I've shown you this one. If you have a sphere, you can also compare the amount of language you have in different corpora. Right? So you get the very large one in comparison. So you can actually show someone how much data you have used in comparison with other types of research. If you have, because we can compute or very easily calculate the volume of a sphere and volume of a corpus in terms of the number of tokens, running words inside the corpus. Right? So there are different ways of approaching this issue. Again, just to show you what we did in Langsbox, and you can do that in the words tool, where you have a corpus as a sphere, a second corpus that you can sort of compare with your original corpus and run keywords analysis, if you like, if you sort of drag them together as a sort of a comparison metaphor. But you can also expand the corpus to see inside, to see the different genres and different texts in the corpus, and to see the variation of a linguistic variable inside the corpus. So this is the type of visualization that Langsbox would provide for you and for your data if you were interested in that. Okay, so the question that we are going to address now is, what can we see in the data? Right? We are talking still about data visualization. Here's a table taken from a research report. The details are not important, just to mention that this is a table reporting collocational statistics using the MI score, if you are familiar with that, in different corpora. So we have different corpora over here, and we have different collocations and different scores for these collocations inside the table. As I said, the details are not important, but what would be your first reaction to this table? Do you like it or not? Some people shake their head. Why not? Yeah, you have to, work really hard, and there are sort of many things going on in the table. So you would like the comparison of those in some way. So we could sort of rework the table in some way. Any other observations about the table? Yes. Okay, so if you were to compare, that's a fair point. If you were to compare the numbers, you would, I think the intended comparison was the comparison across the corpora here, right? So you would sort of read it horizontally. But of course, depending on what your research question is, you might like to reorder the data. But I think there's one fundamental problem with the table in terms of its basic readability. Well, we would need sort of some annotation. But even at a more basic level, and this doesn't help very much because this is what Microsoft Word would produce to supposedly help you, right? Well, it would just add color to the whole mess, right? So, it wouldn't be that great. What I'm sort of trying to get at is really that the table has two components. One is the data, and the other thing is the graphical thing. The borders, the shadings, and all that. And these are actually, fairly similar. But if you take away the mess, the table becomes more readable, right? Again, depending on your research question, you might like to restructure the data. But in this example below, I've taken away the lines that actually, didn't serve much. They were just cluttering the whole picture. So by just, very simple removal of some of the elements of the original table, I was able to reach more readability for the user. And I might like to use the color, but in a more intelligent way than Microsoft Word would suggest by default, just to highlight some of the extreme values in the table, right? So the reader can actually see where the where the values are. So the color is not used for just purely aesthetic purposes, but for functional purposes. Right? And this is very important when we think about scientific visualization. Right? There has to be a purpose to what we are doing. Yeah, a lesson learned from our development of the Langsbox tool. You probably haven't seen this because this was version 1 of the tool some time ago when we sort of presented the data, and this is a concordance table. Right? And I think it suffered from the same problems as our original table that I showed you before. Right? All the data was there. It was just too cluttered, and it was very hard to read the examples because normally we read the concordance lines both horizontally but importantly also vertically. But I could see individual words, but I can't see proper examples of language use, and it's very hard to spot patterns if I have that like that. Well, we got rid of the lines very, very, very simply and allowed the user to sort the lines in a sort of more natural way. We highlighted the node word in the middle because it has a special function. It is our search term, what we were searching for. And then we have the patterns left and right if we want to. So from version 2 onwards, now we are at version 3, we sort of implement these sort of simple tweaks. We use color to highlight patterns. Right, again, in a sort of purposeful way. Right, in this case, I'm looking at the combination of sum followed by people in the right context. Right? So again, Langsbox adds this sort of filter to the data and just highlights that. Just a tiny thing. The color also appears here, so you can see that your occurrences are coded and filtered. Right? So there's some kind of consistency in how we apply those color messages. Right? So these are sort of tiny things, but make a huge impact on how we interpret the data and how we can interpret the data and the meaningfulness of the analyses. Okay, another example from our development is connected to the richness of information. Right? Because we have the space given by the A4 sheet or the screen of a computer. Right? And the question is how much useful information you can fit in that space that is basically given. Right? So we start with 0 dimension to 1 dimension to 3 dimensions in a graphical display of collocations in this particular case. So we have the collocates of time, and in a traditional way, and there's nothing wrong with that, we would have a table, list of collocates with all the details. Right? And this is sometimes very useful because we can actually look at the individual value of the statistic and compare them. Right? But sometimes, if we are interested in the relationships in language and discourse, we might like to visualize it in a slightly different way, such as a collocation graph or a collocation network, and we'll have a session on collocation graphs and collocation networks later on. So our version 2 of Langsbox had this type of data visualization, and people quite like that. There was the sort of the search word, the node in the middle, and the collocates around the node, the same thing that I would display in a table. But this time, the statistic would be displayed as the length of the arrows or the edges in the graph, right? And it will be inversely proportional. So the larger the statistic, the shorter the arrow. So imagine this being a magnet trying to attract the collocates, right? However, there was only 1 dimension displayed here, right? And that's precisely just the strength of the association as measured by a particular statistic, like an MI score, T-score, or log dice. Right? The way the collocates were distributed around in this space, in this 2-dimensional space, was just purely for just ease of display. Right? So there was no reason why next should be here and not here, right? And so on and so forth. What we try to implement in version 3, and we are sort of pursuing that with the upcoming version 3.5, where we sort of even made this clearer, is to actually include a few more dimensions to the graph so that we use the space well. One of the dimensions is the frequency. So we have still the length of the edges, right, of the lanes in the graph, representing the statistical measure. We also have the intensity of the color, and here we have just one color for all the collocates. Here we have the intensity of the color for the frequency, right? So we can display both. We can display frequent collocates, but also collocates that are uniquely and exclusively associated with the node, right? So I added another dimension here just by using the color here, the intensity of the color. And the third dimension, and that's why I'm pointing to 3D, is actually the position of the collocate relative to the node. Because as you know, in text, some collocates appear before the node and some appear after. And some appear sometimes before and sometimes after. Right? So here we would display the exact mathematical position of the collocate in text and corpus. Right? So we know that words such as short, waste, same, long, first, at precede time, right? Most of the, in most cases. Whereas words such as ago or saved would follow, right? Some time ago, time saved. Right? Words such as spend can be both left and right, or lost. He lost time, time lost. Right? So it gives you that type of information. So it gives you something more in addition to the sort of basic pieces of information that you have. And that sort of contributes to the richness of the display. Right? Same size of the graph, but much more information. Right? And ideally, this should be our goal in data visualization. Okay, does that make sense? Okay. So when we think about data visualization and implementation of data visualization in our tools, such as Langsbox, we try to follow some basic principles. One of the core principles is the focus on content. And content is the data, right, the corpus data. We don't want to display anything that is superficial, but we want to display things that relate directly to the data. So, that's one of the reasons why the tool itself is in sort of shades of gray, sort of grayscale, whereas the data is displayed with color. Right? So the tool is in the background, the data is in the foreground. So one of the principles of the development. We also focus on comparison, because comparison is actually one of the key scientific processes where we want to compare. In science, you usually have your treatment group and your control group. Here we have, in corpus linguistics, our corpus of interest and a reference corpus, perhaps. So, we need to have a way to compare data. And of course, we want to visualize data in some meaningful way, and we can still improve those visualizations. Okay, so just to sum this up and come up with some more general theoretical principles about good data visualization. So again, drawing on Tufte's work, the focus should be on content, comparison, and causality. Causality is actually explanation and interpretation in science. Right? We want to see, and obviously not always can we arrive at clear causal links in observational data, as in corpora, right? Because corpora are not experimental data, but observational data. But we want to strive for finding the patterns and reasons for why we see those patterns, right? So in science, we would talk about causality. And Tufte sums this up very, very nicely he sort of says, if a picture isn't worth 1,000 words, the hell with it. Right? So if you can't provide a nice visualization that will be meaningful, there might be other ways of doing that. So don't just display pictures because you can, or because you need to, you have 10 pages to write, so it's nice to have like five pages of pictures. The way Tufte tries to implement this is through the notion of data-ink ratio. And a successful type of visualization would be a visualization type that has high data-ink ratio, right? That would allow us to see the data above all, as Tufte puts that. So here's an example. Obviously, this is a sort of pre-referendum poll in 2016, and published in one of the British tabloid papers. I think it was Daily Mail that published this one. And again, we can sort of think about this as a sort of a way of visualizing data. We have a bar chart here. Would you say this is a successful data visualization or not? Some people shake their head, people nod. Because Obama visited Cameron before the referendum. Obviously, he was here. So this is just reporting on the event where former American president visited Britain before the referendum. I think this is Remain and this is Leave, but we know that it's turned out the other way around. So you would sort of assume that it is connected to the people in the background, yeah, well, and rightly so. Yes. Why else would we have that type of thing? Ambiguous in what sense? Absolutely. Yeah, there's one question, and we have to, then seek interpretation in some way. And again, the picture doesn't provide much guidance. Any thoughts? So yeah, the scale here, right? Because we can lie with the data quite easily. If we sort of stretch the scale, we can achieve anything, and even sort of seemingly large difference. That's a great point. That's also a good point, whether there are sort of undecided people that are not displayed here, because they, they probably sort of did matter in the event. But yes, but the graph doesn't tell us, so we just don't know, right? So well, obviously, we can't judge a newspaper article and a newspaper graph published in a newspaper by the same strict academic standards as we would sort of judge a graph in a journal article or sort of research report, right? Because they are appealing to different, using different strategies. Obviously, they, especially tabloids appeal to people's emotion rather than, the rational argument, arguably. But so, this might sell the newspaper quite well when you think about that. So it might be actually, very successful type of visualization from the newspaper perspective, but clearly it wouldn't cut the mustard from the perspective of an academic visualization type. So, well, if we just get rid of things that we don't need in the graph, that doesn't contain the content and information, we just end up with these two numbers and perhaps the question, right? Maybe, a line of text would say the same thing, and we would save all the space here, right? That we can, use to perhaps analyze the situation, but that would be probably too much to ask from some of the newspapers. So what we are really after in scientific visualization is some kind of a minimalist approach, right? Remove redundancies in the data and focus on the gist. Right? So again, I have a figure here that I produced, and that's the figure, the frequencies, absolute frequencies of the word love in the British National Corpus. What we have here are multiple redundancies when you think about that. So obviously, the one piece of information, that is the frequency, is displayed multiple times. And if you do the counting with me, you can see that it is displayed about 7 times in the graph. You know, it's the line on the left, the line on the right, the bar itself, then the position of the text, not the text itself, and also, when we think about that, the information on the y-axis, and finally, obviously, the number itself, right? So if I just put the number there, I would present the same type of information, but once here I have multiple redundancies. So ultimately, what Tufte proposes to do as sort of a check about how efficient different types of visualization might be is to compute a simple ratio that he calls data-in ratio. And this is the formula for the data-in ratio. Well, you know, we don't have to worry about that too much. It's more of a sort of general principle, but I'll show you in a moment how this can actually be computed, although, you know, we don't do that too often. The data-in ratio obviously takes the ink, and this is the metaphor when you print something, right? You'll print your graph, and you use some ink to show the points in the graph. So the data-in over the total ink used to print the graphic. So imagine this graph, and it is very easy to produce one in Microsoft Excel, right? A graph like this one. Well, you would probably agree that in terms of the data visualization, this is not the most efficient graph, and it uses a lot of ink in your printer. So if we were to calculate the data-in ratio, by the way, this is a scatter plot plotting the definite article on the x-axis and the personal pronoun I on the y-axis, and just seeing the relationship between these two. We would get, well, obviously, there's a bit of redundancy almost in the labels as well, and Excel would prompt you to put the graph title at the top, and then you would have the label of your figure in your research report. So again, that multiplies the redundancies. But when we just calculate the data-in ratio, imagine that in a printed page, this would be sort of 10 to 10 centimeters, or so a square, right? Data-in ratio in this case, you know, when we think about the data points, so the data points are these points, right? We have 64 data points, and this is the size of the data points, and this is the size of the graph, and we would get something like 0.16. The data-in ratio is a number that ranges from 0, very bad visualization, to 1, very efficient type of visualization, and this is fairly close to 0. Right? In contrast, if we look at a graph like this one, right, that we perhaps can produce more meaningfully, and this graph was produced in the Lancaster Stats Tools Online, that actually sort of try to promote good principles of data visualization. So when we run the data-in ratio equation here, we can see that we get something that is much more successful. Right? What we have here is also not only the points as here, but we also have the labels that point us directly to the speakers in the corpus. Right? We can also see by the labels, because we have F for female and M for male, the gender of the speakers. So already in the graph, we have so additional pieces of information that we can use for the analysis. Right? So again, we have 64 points, slightly larger pieces of information, but we don't use the ink to fill up all the space. We use that just for the axes, and then when we run the numbers, we get closer to 1. We can even improve the graph if you like. Get rid of these 2 lines to just have the bare minimum. Right? And I would be quite happy with this graph being sort of published or presented in a research report. Okay, would this sort of make sense? And these are sort of extreme examples of how we want to think about the data. And again, I'm not suggesting that we should be calculating data-in ratio for every single data visualization that we do, every single graphic. But it is more of a sort of principle of thinking about data and data visualization that we should adopt, perhaps, and try to be critical about how we present the data. Okay, some examples of good and bad graphs, and pie charts are favorite graphs because they can be produced very, very easily in packages such as Microsoft Excel and Calc and other packages. Can anyone see any problems with this particular graph? So it is a student survey. 33% agree and 67% disagree with that question. Yes. So you would sort of place it next to each other. The label here. Okay, great. Yeah, you will be able to tell, but like with the angle, you might not know whether this is like more 40 or 30, 35. So in a way, depending on the precision that you need to have. But that's a fair point. Yes. Any other thoughts? Yeah. Go ahead. What would you do? We might like to know the question, right? Okay, brilliant. So you think the choice of color actually is something to look at as well in terms of what we want to highlight in that. And can anyone see any other issues with that? Okay. If we don't want to just fill it with too much color, and obviously, as you pointed out, this is the title inside the graph rather than sort of proper label of the figure. Any other thoughts? Okay, so if you want to use this space better, you would be able to do so. Yes. Maybe a sentence will do for that, because this one takes up a lot of space. Arguably, that's a very good point as well. But of course, you have different pie chart options, but that doesn't help, right? One fundamental problem is that it might hide some of the values behind the chart, right? You might be just hiding the fact that you sort of only managed to find 3 people in your sample, which is, from the statistical point of view, a sort of crucial point of detail, because obviously, this sample would be fairly small. We can't base any conclusions on that. But we wouldn't know from the 33% because we could have asked 300 or 3,000 students with the same pie chart applying. So again, some of the data visualizations can be helpful, but some can be unhelpful in various ways, as we discussed that. Again, this is a very popular graph that comes from the Google Ngram. Has anyone used Google Ngram before, right, or seen Google Ngram before? There's also a sort of a scientific or pseudo-scientific, if you like, discipline based on this Google Ngram analysis called culturonomics that sort of produces graphs like these and draws implications about language and culture and the development of language and culture. Because what we have here is a graph, a diachronic graph from 1800 to 2000. Right, based on the Google Books sample, which is a huge sample, right? And using the Google Ngrams, we can sort of search the corpus, if you like, but I would, I would hesitate to call it a corpus in the proper sense, and find out the development of words such as immigrants. Right? So. Based on this, people would normally conclude that there's a rise in the discourse around immigration, right? From 1800, we have almost no to 2000, and people could draw some implications and how immigration becomes a major problem and all this. Well, the problem obviously is that we have no access to the examples. We don't know what is happening. We know with Google Books that the sampling frame has changed over the years, right? So when we are talking about scientific text, we get sort of the rise of scientific text later on. So we are not comparing like with like. Also, the word immigrant might be sort of fairly new word, right? Think back in 1800, what would be the label that people would use for the group of people who sort of travel from one place to another? Right? Pilgrims. Think about this: competing naming strategies that will be at play here, right? But the graph would just suggest one type of interpretation, and I think that's the sort of obvious risk. If we don't have enough information, then this graph wouldn't be meaningful and wouldn't have a meaningful interpretation. As many as you like, but it doesn't get better. There's another example of culturonomics that sort of uses place names in New York Times, I think, and this graph is based on just sort of different place names mentioned in the newspaper. Well, I hardly see the map of the world behind that, and I can't really make sense of this very complex network. Probably as a work of art if you want to, display it somewhere, but as a sort of type of scientific visualization that actually wouldn't work very well. And people, when you have lots of data, people sometimes produce things like these, and it's not very useful or informative. Okay, some okay-ish examples. We already sort of mentioned that. So when we have bar charts, the question is, do we really need them, and how much information we can display in bar charts? Obviously, in this particular bar chart, we have 3 corpora and we have 3 values, right? So we display 3 numbers in this whole space. If we have something like a box plot, and I mentioned box plots in yesterday's lecture, we might be able to actually display more information, right? Just to remind you, what we see in a box plot, again, it is the same type of data as in the previous bar chart. Right? So we have 3 corpora, and we can display them like that. What we see is the maximum value, the minimum value. We can see the median, right? That's the middle line in the box. And we can also see, and that's the box itself, what we call an interquartile range, the 50% middle values in a distribution. Right? So we actually know quite a lot about the data, and we also have a lovely outlier here. Right? So again, we can look inside the corpus and see, okay, why this particular data point is away from the rest of the data. Right? Is there some measurement error? Is there any particular reason for this? We can go even further, and this is a sort of a enriched box plot that the Lancaster stats tools produce, and we can actually overlay some more pieces of information in the same graph. So what we display here are the individual data points in addition to the general statistics, and we also display the mean, which is the red line here. Right? So we have both the median and the mean in the graph. So when we count this, we get something like 36 pieces of information as opposed to 3 pieces of information in the bar chart. So in a way, when we think about the competition for this space, this is a clear winner. We talked about collocation networks, so again, an alternative to a table when we want to display collocation relationships. I'm not sure if you are familiar with sparklines, but sparklines are really, really useful if you want to see some clear trends in data and sort of have a brief summary. A sparkline is a tiny graph that takes up space of a single word, right? Takes up space of a single word. The data here is based on Tony McHenry's book on prostitution that you can read if you are interested in this social topic, prostitution in the 17th century. But what we can see is that there are different naming strategies for people who we would now call sex workers, perhaps. Whore was the most frequent one in the 17th century, followed by harlot, but that one declined. And prostitute is a word that came into existence as a noun in the 17th century. It started as a verb, but sort of became a noun in the 17th century and became used as a noun in the 17th century. And all that can be summarized in 2 lines of text and 3 tiny sparklines. Right? The sparklines show the trend, but also show the minimum and the maximum. Right? So they highlight in a very tiny space lot of data. Imagine, and actually, just realize that behind each of those graphs, there's 100 points of measurement. So each of them has sort of 100 individual points of measurement. Right? So sort of condensed type of information that can be very, very useful. And obviously, sparklines have very high data ink ratio. Okay, we talked about geomapping, and this is, again, what you've seen already. These are the places that people in the British National Corpus go or travel to. And again, when we have geolocations in a corpus, we can always put them on a map just to see what is happening in this perspective. And again, this is a graph that we will be able to reproduce in the computer lab using the Lancaster stats tools online. Okay, just a few more graphs. So we talked about a scatter plot with a regression line, and there can be some useful labels, right? We'll talk about correlation and how to compute correlation, but we can also visualize correlation, such as Pearson's correlation here in this graph, in this correlation matrix. Some correlations are positives, some are negative. The positive ones are here in blue, the negative ones are in red, and the intensity of the color is the strength of the correlation as an effect size. Right? So we can actually spot immediately the relationship between many variables in this correlation matrix. What I'm plotting here are different linguistic variables, such as the past time, past tense, perfect aspect, present tense, place, adverbials, time adverbials, and so on, right, against each other, how they correlate with each other in text in English. Right? So again, I can display this efficiently. So I would take 5 minutes as a break, and we shall move over to the computer lab, the stats computer lab, and try some of these things in practice.